folks, welcome back for number 3. So let's take a look at this radical equation with a fun little fraction here and see if we can solve for x. So my strategy on things like this, if I can get rid of that radical, and in this case it's a square root, that's the first thing I'm going to do. So I'm going to take the square root of 2x minus 3 equal to 1/2 x, and in order to get rid of that square root, I'm going to square both sides. Well, and I just saw my equal sign kind of got folded into that. Let me make that a little clearer. Okay. And so when we have a square root of something squared, those are inverse operations of each other, so they're going to cancel, and that's going to leave me with 2x minus 3 here. And then we have to remember that this is, if I write out 1/2 x squared, let me make sure you can still see that. Yeah, that's 1/2 x times 1/2 x. 1/2 times 1/2 is 1/4. X times x squared, right? And for some folks, now that there's this fraction, you might be thinking, oh, I don't really want a fraction in there. If you want to get rid of the fraction, which I tend to do, I'm going to multiply both sides of that equation by the least common denominator. So let me put this in a little bracket. And the LCD in this case is just 4. There's only one denominator, it's 4. So I'm going to multiply both sides of these equations by 4, and then I get to keep the equal sign. So I'm going to take 4 times 2x minus 3, and that's going to equal 4 times 1/4 x squared. And the nice thing about that, again, is that the 4 and the 1/4 are going to cancel. That's going to leave me with just an x squared. And I'm going to go ahead and distribute here, and I'm going to get 8x, 4 times 2x, minus 24. And so now I have this quadratic equation. Oh gosh, and I just saw my typo. Maybe you saw it before I did. It turns out 4 times 3 is not 24. It is 12. So let's adjust that. All right, now I have a quadratic equation. We've got 3 techniques for solving quadratic equations. We can factor, we can complete a square, or we can use the quadratic formula. I'm going to try and see if I can factor first, only because that's a quicker method. And if that doesn't work, I'll use the quadratic formula. But if I want to factor this, the first thing I want to do is get everything on one side of the equation. So what I'm actually going to do, I'm going to add 12 to both sides, and I'm going to subtract 8x from both sides. All right, and what that will ultimately do is leave me with a 0 over here and x squared minus 8x plus 12 on this side. So let me go ahead and rewrite that here. I've got x squared minus 8x plus 12 is equal to 0. So now I'm looking for 2 numbers that multiply to positive 12, but add to negative 6. And depending on how comfortable you are with factoring, you might be able to feel out that if I used negative 6 and negative 2, I could do that, right? Because negative 6 minus 2 is negative 8, but negative 6 times negative 2 is positive 12. And if you can see that through factoring, great. And if not, use the quadratic formula. The quadratic formula will always get you to an answer. It just takes a little bit longer, right? Factoring, not everything factors, but if it does factor, it goes faster. So that's kind of the trade-off. Factoring can be faster, but doesn't always work. Quadratic formula takes a little bit longer, but always works. All right, so as I start to look through this, I'm going to have that either x minus 6 is 0 or x minus 2 is 0. So either x is 6 or 2. Because I would add 6 to both sides and then add 2 to both sides over here. Now, before I click off 2, 6, right, as the answer, I'm going to rule out C and D. Those are not the answers. But I do want to check that I don't have an extraneous solution. Because sometimes when you do the square root stuff, right, when you square both sides, there's times when you'll get an extra answer that actually doesn't work ultimately with your original problem. So what I just want to do, I just want to plug 6 back in to both sides of this equation, make sure that solution works, and I want to plug 2 back in. And if I look at my options, it's really 6 that I have to check. It looks like 2 is definitely going to work, and I just have to double check that 6 works. Because if 6 works, then I'll circle B. And if 6 is extraneous, if it yields a domain issue, then I'm going to try option A. So let's just try. I'm going to actually start with 2 because we know 2 will work. So let me just check this answer, all right? And I'm going to put like a little wavy bar here just so we can check it. So if I was going to check it x equaling 2, if I plug that into the left side of the equation, that's 2 times 2 minus 3 under the square root. Is that equal to 1/2 times 2? And I'm fairly confident this will work because both A and B have the number 2 listed. All right, 2 times 2 is 4. 4 minus 3 is 1. So is the square root of 1 equal to 1/2 times 2? Well, the square root of 1 is 1. 1/2 times 2 is 1. This checks out. So that's why I want to definitely keep x equals 2 as a solution. Now let's just check x equals 6. Let's see if that works. So I'm going to plug 6 in for x. So is the square root of 2 times 6 minus 3 equal to 1/2 times 6? And I always put a little question mark over that equal sign until I determine, yes, it is equal, or no, it's not. All right, so 2 times 6 is 12. 12 minus 3 is 9. So this is the square root of 9 here. Is that equal to 1/2 times 6, which is 3? Square root of 9 is 3. That is equal to 3. So I want to include 6 as my answer also. So ultimately, I'm going to circle B. All right. Thanks so much.